In this video, we will cover the concept of impulse. Now, impulse is defined as product of force acting on an object and the time during which the force acts. So this idea is applied during a collision. The time interval you have to consider is when the collision is actually happening. There are certain mathematical variations. So you have J equals to F times delta T. Some books or some teachers prefer to use the notation I, capital I, for impulse. So that is also true. Now we know that force is the rate of change of momentum. So change in momentum over change in time. So we can simplify it here. Impulse is also change in momentum over change in time multiplied by change in time. So the impulse is the change in momentum. For understanding impulse, we can start from the equation J is force times time, or the force is the impulse divided by the time interval. Let us take the example of a car crashing into a stationary object. The front crumple zone allows the car to come to a stop over a given time of interval instead of just coming to a stop abruptly. It increases the time interval, hence the force experienced, the overall or the average force experienced by the person sitting inside the car is much less, because higher the time of collision, lesser the force experienced. So the design of the car, having the front crumple zone, the rear crumple zone, even the seat belts and the airbags, what they do is that they increase the time of collision. Having all these features is what makes the car much safer. You can also look at similar examples in your day-to-day life, like landing on a soft mattress is much more safer than landing on hard floor. Now let us solve a simple example to use all the mathematical variations. A ball is thrown horizontally at a wall with a velocity of 12 meters per second and rebounds with a velocity of 9 meters per second. The time of contact with the ball and the wall is 35 milliseconds and the change in momentum is minus 7 kg per second. Calculate or find mass of the ball, average force exerted on the ball, and impulse. Now let us write down what do we have. We have the initial speed 12 meters per second, final speed or final velocity minus 9 meters per second. Since it rebounds, we can take it as negative. T is 35 milliseconds, so milli is 10 to the power negative 3, so divided by 1000 we get 0.035 seconds, and the change in momentum is given as minus 7 kg per second. We have to find the mass, the force, and the impulse. So let us start with the equation for change in momentum is mv minus u, or mv minus mu. We can take out m common, so substitute the values and simplify it. You'll get the mass as 0.33 kilogram. The expression for force, we can use change in momentum over time. So we get minus 7 over 0.035. Get the answer as negative 200 Newton. We know that the impulse is equal to change in momentum. So equals to minus 7 Newton second, or you can just write the same unit, kg meter per second. And that is it for the concept of impulse. In the next video, I will cover the force time graph for calculating impulse. Such questions are mostly covered in entrance exams or even in the multiple choice questions. So stay tuned. For more numericals, follow me on Instagram. My account is Solutions by Tall Teacher. Don't forget to like, comment, share and subscribe to my channel. Stay tuned for updates.